All right, ladies and gentlemen, let's talk about lesson 4.4, which is parallel and perpendicular lines. The skills we're working on today, we're going to be constructing functions and we're going to be interpreting the slope and intercept of linear models. So we're going to be looking at graphs and we're going to be looking at equations to figure out how they are related. We have two vocab terms. Oops, not coming on a click, but that's okay. Our two vocab terms are the term parallel lines and perpendicular lines. Parallel lines never touch each other. They're in the same plane, never intersect, and have the same slope. Perpendicular lines are lines which meet at a 90-degree angle to form right angles, and whose slopes are opposite reciprocals, which means that if we multiplied the two slopes, we would get a product of -1. Opposite meaning negative and reciprocal meaning we would flip that fraction over. I like this little image out of the textbook because it helps show you some of the symbols that we're going to be using. The symbol for parallel is two parallel lines, and the symbol for perpendicular is a set of perpendicular lines. When we're talking about parallel lines, it looks like the examples we have here where they never cross, whereas our perpendicular lines meet at a 90-degree angle. If I were to multiply the slope of EF by the slope of the line GH, I would get a product of -1. So let's practice here. Write the equation of a line that passes through the given point and meets the constraints given. So we're bringing back that idea of constraints that we talked about earlier in this chapter. I see an ordered pair of 3, -2, and I want to make the line that goes through that point parallel to the line that goes through, or that is, y equals x plus 4. So with this first example here, the first thing I need to find is the slope. If I look at that first equation, I see y equals mx plus b. Well, that m value, the number in front of x, is invisible here. It's really a -1. So now I know I need to have a slope of 1, and it needs to go through the point 3, -2. So I'm going to write this in point slope form because that's my easiest way to do it. I know point slope from my last lesson, y minus y1 equals m times x minus x1. Oh, come on, x1. I'm going to plug in my pieces. I have an m value of 1, an x1 value. I see x1, y1. My x1 value is 3, and my y1 value is a -2. So minus a -2 is going to be the same as plus 2. Well, now I want to write the equation of the line in slope-intercept form. So what I'm going to do is I need to shuffle things around so I have y equals mx plus b. To distribute a 1 doesn't change anything here, so I'm going to have y plus 2 equals x minus 3. Last step, take away 2 from both sides, and I get y equals x minus 5. This line is parallel to this line. I see that my slopes are the same, but now I'm going to go through this given point here. And in my instructions, it didn't actually tell me it needed to be in slope-intercept form, but I'm saying that we should write it in slope-intercept form. In the homework, it's more clear about what form your final line should be in. For this next one, I'm going to do the same thing. I want it to be in slope-intercept form at the end, but this time I want it to be perpendicular to the line y equals -2x plus 4. Well, to find the perpendicular slope, I need to have the opposite reciprocal. So the opposite of -2 is +2. The reciprocal of 2 is 1/2. So my perpendicular slope is going to be 1/2. And now I'm going to do the same process I did before, where I'm going to use y minus y1 equals m times x minus x1. So let's label these pieces again. I have x and y. My y minus a -2, which is the same as y plus 2, equals my slope times x minus x1. Well, x1 is negative, so minus a -3 is the same as plus 3. I'm going to simplify by getting rid of my parentheses this time, and I do need to use the distributive property. I get y plus 2 equals 1/2 x plus 3 over 2. And I take away 2 from both sides, and I get y equals 1/2 x. 3/2 is really 1.5. 1.5 minus 2, well, that's going to give me 1/2, or 0.5. If I were to graph this, I would see that this line with a a slope here. We'll do a sketch here. I'm not going to actually graph it out. A sketch of this one here, it's going to go just below that y, or the x-axis, and it's going to have a slope of 1/2, so a kind of shallow slope. This one here has a steep negative slope, and it goes through +4. So we would expect it to look something like this example that I have here. I can write the line that is parallel with a given point, or I can write the lines that are perpendicular. Well, now let's look at this situation here, and this is a homework problem. This is from page 242, it's number 6. I want to determine if the lines given are parallel, perpendicular, or neither. Well, when I'm trying to evaluate this, I want all of them to be in slope-intercept form. And I can see these ones are all going to be direct variation. Oh, no, not quite. All right, ignore that part. We're going to write them as best we can into slope-intercept, the y equals mx plus b form. This one's already ready to go. My next one here, well, I want y by itself, so I'm going to divide both sides by 3, which gives me y equals 1/3 x. And then my last one is y equals a -1/2. That one's a constant function. Well, one way to solve this is I could graph these 3 lines and visually determine the relationship. If I did that, we'll do a sketch of a graph here. Y equals 1/2 x. That's going to go through the origin, and it's going to have a slope of 1/2. Well, my next one, again, it's going to go through the origin here, and this time it's going to have a slope of 1/3, so a little shallower. And my last one, y equals -1/2, well, that's just going to be a flat line through y equals -1/2. Visually, I can see that these lines are not related. There is no pattern. They're not parallel. They're not perpendicular. It would be even more apparent if I had it on an actual coordinate grid. But the other way I can do it is I can analyze these equations here. I see a slope of 1/2, a slope of 1/3, and a slope of -1/2. None of these combinations are opposite reciprocals. That's a tough thing to say. Try to say it 3 times fast. The opposite reciprocal of 1/2 would be -2. The opposite reciprocal of 1/3 would be -3. And the opposite reciprocal of -1/2 would be +2. So these lines are not parallel. There's no slopes that are the same. They are not perpendicular. There's no slopes that are opposite reciprocals. So in this case, these 3 lines have no listed relationship. That's enough sample problems here. I want you to get started on the homework. We've got assignment number 7 from page 242. You're going to do problems 1 through 10, 32 through 36, and number 47. Number 47 is one of those critiquing the reasoning of others. You're going to look at 2 students' work and determine who is correct if either of them is correct. It's a little tricky. Not quite as hard as number 48 on last night's homework. Go ahead and get started. Thanks, guys.